internet doesn't go out.
Yeah, me too. Okay, so first thing we need to know what a system of equations is. Okay, a system of equations is basically when you have more than one equation. We are talking about linear equations right now. So basically what we've talked about before, y equals mx plus b, that's a linear equation, or ax plus by equals c. This is the slope-intercept form. This is your standard form. Both of them you can graph. This one you just use the slope and the intercept to graph it. It's the easier, more useful form. Okay. This one is where you put in your x equals 0 and your y equals 0 to find the intercepts, and then you can graph it. Okay. So in this form, you use m, and you use 0b as your intercept, y-intercept. Intercept.
C.
Yep. Okay. This one you make x equals 0 and find y equals. You make y equals 0 and find x equals. This is your y-intercept. This is your x-intercept, but then you can graph. Okay, you graph using the slope. This is the change in y over the change in x. That little sign that looks like a triangle can mean change. Okay, that's in math, that little triangle means change. So, when we have a system of equations, that means we have more than one. Okay, so it's more than one equation. So a system of equations is more than one. Most of the time we are going to do 2. Okay, we're not going to do 3 and 4 and 5, but we can. You can do that many. Okay, but we're going to look at just when there's more than one, where there's 2. Okay, now let's talk about solving. Okay, when we solve for an equation, solve for an equation. What are we actually looking for? Like if I say x equals 0, and I want to solve for y, what am I actually looking for there?
You're looking for the y-intercept?
I'm looking for the y-intercept, but what also is it?
The x-intercept.
No, it's
but
not the
x-intercept
x-intercept.
is 0.
Yeah.
Would it be a point?
It's a point. What kind of point? It's a point that does what to the equation?
Makes the horizontal line.
Doesn't make the horizontal line.
It makes the vertical line.
Okay, let's start here.
Just
If I
the
say
opposite of
y
where it says.
equals 3x plus 5. If I put 0 in for x, what am I going to get?
5.
5. Why do you know?
Because anything times 0 is 5.
Okay.
0.
So if I plug these points back in, 5 equals 3 times 0 plus 5, what happens? Is that a true statement?
Yeah.
Will all points that are on that line make that equation true? Will all points on a line, if I were to draw this line, 3x plus 5, 1, 2, 3, 4, 5, go up 3 over 1. If I draw that line, what is true about all those points that are on that line?
That they're part of that.
Yeah, they make that equation true. To solve for an equation, we are looking for the points that make the equation true. Okay, so that's what solving for an equation is looking for all the points that make that equation true. Okay, that is represented by a line on the graph. So for solving a system of equations, we are looking for what is the one point that makes both of our equations true. Okay, so let's say I had another equation that came down like this, okay, which is this equation I just wrote, y equals negative 1x plus 5, okay. So now I have these two equations, equation 1 and equation 2. Those points represent all the points that make this one true. This point represents all the points that make this equation true. Which one makes both of them true? Which point makes both of them true?
Y equals 5.
Yes, when y equals 5 and x equals what?
0.
0.
0. So the point 0, 5 makes both equations true. So basically what we're looking for to solve a system, we are looking for the point that makes both equations true. We can see that graphically when we put it on a graph because we can see where they intersect. Okay, so we want the one point that makes them true. Sometimes we get more than one point. When would that be?
When y equals something different.
Well, let's see. Let's think about it.
Well, more than one.
So, solving system equations, most of the time, we get 1 point. Okay, that's all we get is 1 point. Okay, I would say that's about 95 to 100% or 99% of the time.
Yeah.
Okay, but there are special cases, and we'll just give you a couple here. Okay, y equals negative 3x plus 2, and y equals negative 3x plus 7. Okay,
So
this
it's
is
negative 3x is the thing.
let's see what happens. If we graph those two lines, do you agree there's two lines there?
Yeah.
Okay. If I were to graph the first one, this one, what's my y-intercept?
2.
2. So I go up 2, and then what is my slope?
You go down 3.
Down 3 and over how many?
1.
1, let's see, here's 2. 1, 2, 3 over 1. So here's my line, right? Perfectly drawn. So this is y equals negative 3x plus 2. That represents all the points that make that true. Okay. How do I graph the next one? Line 2.
Same thing.
Really? Does it go through 2?
Don't listen to me.
It goes, what is its y-intercept?
It's
7.
7.
7.
Not same thing,
Okay,
but same
two,
equation.
5,
Not
6,
equation.
7. And then how many do I go down and over?
3.
1, 2, 3 over 1. But my drawing is not very good because I didn't space these equally, so it's going to be harder for you to see. Okay. You should get There, a beautiful line. That's what you get.
Wowzers.
What is true about those two lines if I do them accurately?
They don't cross.
They never cross, they're parallel to each other. So a special case is when they never cross.
It's not the 1% of the time, or is there other exceptions where you
There's
get
one
three
other
points?
exception. So this is one.
If there were
They
decimal.
never cross. So what would I say? Do they have a point that makes both of them true?
No, so it's untrue or
Or
like
no
invalid or-
solution.
yeah.
Okay, this is
How
called
would you say?
no solution. Because there is no point. If you said no point, I'd take that too.
Yeah,
Okay.
so there's just no point in solving.
What's the point?
Yeah, what is the point? Okay, so the second one is a little bit different. And when you come into this, it's usually when you have something like this. We'll just use that first one again. And
Huh.
usually you will find something like this, where they give you one in slope intercept and one in standard form.
Seriously, somebody's gonna deja vu.
Yeah. Can you switch it?
Switch what?
Can you switch the two on the bottom equation? The 2 equals y plus 3x. Could you switch that?
Why?
Because it just doesn't.
It's messing with his brain.
It's messing with your brain.
It's
So
messing
let's
with my
I bet you
brain.
just switch it on my paper.
let's graph these, because this is a good review for you guys. One of them slope intercept. Okay. This one we just drew, right? So we go up 2, there's my first point, go down 3 over 1. It's right about there. It looks like that, okay? That's how you graph y equals negative 3x plus 2. Okay. Now, to graph this one, we're going to do the x equals 0. So we're going to do 3 times 0 plus y equals 2. So y is equal to 2. So that says to me, my point is 0, 2. Oh, looks like they cross at 0, 2. I'm going to do a different color just so we can see where the line is. Okay, here's my other one. It's right there. Okay. Then if I do y as 0, my second thing is I do y as 0. So I get 3x plus 0 equals 2. Divide by 3. So I get x equals 2/3. So that's the point 2/3, 0. So I'm going to graph that. Huh. 2/3, 0. Huh, if I draw that line, well, see, I have to be very squiggly. What line is it?
Go up 2, then to the right.
They're the same.
They are the same. How many points do they intersect?
All of them.
All of them. Okay? This is the other space,
Which
is
means
when they
infinity.
are the same line. So case 2 is when they're the same. How many points do they have in common?
Infinity.
Yes. Infinite solutions. Because they're the same line. And if you just tell me they're the same line, we should know that they are
True statement.
yeah, they're all their solutions are gonna be the same, because if they're the same line, they'd all have to be the same. Okay. You guys all noticed I just moved the 3x over, right?
Yeah.
So I made them the same by just moving 3x over. I added 3x on both sides, and so I knew they were the same line. Okay. So that's how you can tell. Those are the special cases of doing this. Okay. So we are working on solving systems of equations. So these don't happen that often. I wanted you to see that they do once in a while, where you get no solution or infinite solutions. Most of the time you're going to get 1 point. Because really, if there's no solution, it really tells us nothing. And so when we use this in business, they look for break-even points. Those are the points where my sales, how much I charge, and how much I sell an item for, and all the costs that we have associated with that, we want those to cross, and that's called your break-even point. And so it's two different equations that you're using, and you come up with that, okay? So that's basically what we're looking at. So let's just go back. My problem with doing some of these is that my scale drawing of a graph is not good up here. But it works. We'll try it, okay? So let's just come up with, I'll give you another equation, okay? So we're gonna do y equals 7x minus 2. And I have to think of the point where they cross. And when I make these up, it's a problem. Okay, we're gonna graph these two and see what happens. I have no idea what's gonna happen.
This isn't looking too good.
Oh.
I just grafted one of them.
You grafted one of them. You
Isn't
grafted them,
that
all
when you
right?
take
I
the
drafted
target-
it. It's on a different team now.
That's not grafted.
Drafted.
Drafted.
Yes, you drafted
I
them.
drafted the graft.
Okay, so I'm gonna go down to
The graph is kind of.
up 7. I say 1, 2, 3, 4, 5, 6, 7, and over 1. So I have the line, whoops. You have to draw it carefully, okay?
That sounded like a seagull.
Mine is drawn very accurately, don't you agree?
Very.
Very accurately.
Please give me more points.
Okay, the next one is plus 5. 1, 2, 3, 4, 5. And negative 1 over 7, so down 1. Oh boy. 1, 2, 3, 4, 5, 6, 7.
1, 2, 3, 4, 5, 6 across. It's just gonna be a little.
It's gonna be right in here somewhere.
In here somewhere.
You know what's this is an example of?
What not to do.
Yeah. This is an example where you can't find the exact answer because it's not on a whole number point.
So you
Okay.
use decimals.
Well, you can use decimals, okay, that's one way, but right now, that's why we use other ways of solving them, which we're not doing right now, we're doing graphing. It's hard to come up with these that give whole number answers, okay, right off the top of my head, okay? Hence, why I'm going to give you a worksheet
No.
that has problems on it.
No. Give us a worksheet that doesn't have problems on it.
Well, that would not be a worksheet then.